we know roots of a lot of crops go down very far, 2 to 3 feet deep. The large majority is shallow, but we have crops that'll go super deep. Why are fertility recommendations based on 6 inches? Or Mississippi is unique in that our soil testing lab and our recommendations are based on a different soil extraction that's not used anywhere else in the country besides a little bit of Alabama. And how come you all use this? Or why do we use an extraction and not totally digest soil nutrients from soil? A lot of the stuff we get is more of a baseline. Where do things come from? Where do we come up with our recommendations on a lot of this stuff?
Welcome to the Crop Science Podcast Show. My name is Brian Arnell, and I am coming to you from Oklahoma State University. This show is brought to you on behalf of Wise and Eddie. Excited today to have on this podcast show with us Dr. Vaughn Reed, Assistant Professor of Soil Fertility at Mississippi State University. Vaughn and I have a little bit of history going back to his time at Oklahoma State. Vaughn, how are you doing today, bud?
I'm good. How are you?
I'm doing well. So Vaughn, tell the audience a little bit about how you ended up at Mississippi State doing soil fertility research and teaching.
Yes, so I've been here about a couple years now. Just eclipsed year two. I started from Kentucky, did my master's and PhD at Oklahoma State under and then did a short stint at the University of Kentucky doing a postdoc before I made my way here. Like I said, been here 2 years, and 2 years really feels like this is the first full year of I'm actually doing things now. I'm actually kind of sort of understanding what's going on. But at least
you're starting to be a productive citizen of academia.
Exactly. I'm at least telling myself I know what I'm doing.
So Vaughn, what are some of the things you've been working on lately down south?
So most of my work is focusing on phosphorus and potassium at this point in time, soybeans, mainly soybeans and corn, have dabbled in a little bit of cotton, specifically with potassium. Haven't really gotten my way into phosphorus yet, and even doing some potassium work in sweet potatoes. So most of my stuff, I think most every university is going through it right now. Is we're talking about, well, where are our recommendations at? Do we need to update them? Do we need to change some things? And so my work has been really focusing on maintaining or updating our fertility recommendations for all crops. Again, mainly in phosphorus and potassium.
So you're not our first Mississippi State person on this show, but give a little bit. So I want you to spend just a little bit about the uniqueness of some of the Mississippi State's cropping systems. Some of the things that y'all do that may not be universal, especially Corn Belt. And then we'll drop into some of the uniqueness about the soils, because you're one of the first soil scientists I've been able to have on. So we can talk a little bit about that.
So Mississippi crop production kind of falls into about 3 different regions. You've got the Northeast region, which is just south of Tennessee. It's going to look very similar to that region, Tennessee, Kentucky, northern Alabama. We're talking corn, soybeans, and across all the state, corn, soybeans, and cotton are our main crops. That region, the Northeast region, it's very reflective of other parts of the state. You've got the Black Belt region, which is Mississippi's real weird, if I can say that in a non-insulting manner.
It's unique, Vaughn.
It's very unique. That's for sure. The soil type, and in this Black Belt region kind of runs into Alabama as well. Super heavy clays, like 27 to 35 CECs. So like this is, there was one day I couldn't even they had gotten 0.06 of an inch of rain one morning, and I couldn't step foot in the field. I mean, it's just so heavy clay. And then you've got the Delta region. The Delta region in Mississippi is very similar to Arkansas, the Boot Heel, Missouri. That's really, as far as the majority of where crops come from, it's from that Delta region. And it's in and of itself also unique.
Is that Delta the more of the traditional alluvial plain with the bands of soil texture differences?
Oh, yeah. You get into the Delta and you'll go from, you'll have some pretty high sharky clays, and then you'll find some below sand out there. I I mean, it's just whenever you get a phone call, whenever I get someone gives me a call, my first question is, what texture? Where are we at? That gives me an idea of, am I doubling my rates on some stuff? Am I pulling back on some stuff? Where are we on this? Because it's a completely different animal out there.
So now that you've been 2 years in on the job, you're starting to get some questions from farmers and educators and agents. What are the most common questions that you're hearing when it comes to fertility?
So most of the producers, and I don't think this is a unique thing to Mississippi. I think this happens a lot of other places as well. I know, in Oklahoma it's a little different, Kentucky is a little different, but a lot of the times our producers have their own consultants, and in this Mid-South region, consultants are a large part of the culture of row crop agriculture. And so since there's a lot of consultants, I'm either talking to consultants or producers who've had some conversations with some consultants in the past. So a lot of the questions I get, now I'm not extension, so I'm not the first, second, maybe the third person they call. I'm generally the very contextual. I have a deep question about fertility or soils.
Yeah.
Get soil physics questions sometimes. And then it gets to me. So the questions I normally get are a basis of, I had a phone call in the airport last week. We know roots of a lot of crops go down very far, 2 to 3 feet deep. The large majority is shallow. We have crops that'll go super deep. Why are fertility recommendations based on 6 inches? Or Mississippi is unique in that our soil testing lab and our recommendations are based on a different soil extraction that's not used anywhere else in the country besides a little bit of Alabama. And how come you all use this? Or why do we use an extraction and not totally digest soil nutrients from soil? A lot of the stuff we get is more of a baseline. Where do things come from? Where do we come up with our recommendations on a lot of this stuff?
Fantastic. So as we move into your research work, kind of dive into some of the more interesting stuff or what you think you're more excited about right now.
So as I said, Mississippi uses the Lancaster soil extraction, developed in Mississippi, really made for the high calcium carbonate content soils in the Black Belt region, and is not used anywhere else. It works very well in that region because there's so much calcium carbonate there. We have like high 8.5 pHs. And so some of the extractions kind of fall apart at that range. A lot of my work in the past 2 years and what we've set the foundation for is not getting rid of our recommendations for that, because there's some locations, some producers that works really well for, but updating our recommendations, incorporating a Malic 3 extraction, something that most of the country uses, most of the producers, consultants, and soil testing groups outside the university system in Mississippi that they use. So we've been looking at updating those recommendations. Some other stuff we've been looking at is, and this is kind of stemming from stuff we worked on in Oklahoma, I worked on shortly at Kentucky, understanding where our recommendations aren't working. Because they don't, I mean, I'm not telling you anything you don't know. They don't work. They, on average, work. And so trying to find and understand the locations or the situations in which that our recommendations work really well, and other times where they kind of fall apart.
So I'm going to go, Chase. I guess we'll background a little bit because not every listener on here has a high level soil fertility course or have gone through soil chem. So spend briefly. You mentioned Malic, you mentioned Lancaster. Kind of talk the differences and throw in Olson and Bray and kind of just give a general understanding background on you said Lancaster's used for the high calcium carbonate, the high carbonate soils, which we'd also utilized Olson on. So kind of get into why we need different extractions and why soil fertility, soil testing has gone through a host of extractions over the last 50 years, and we tend to still have a couple new ones come on the scene.
So back in the infancy of soil fertility and some soil chemistry, it was all, it's still kind of regionally based, but it was all regionally based recommendations. When we were really starting to understand, or at least attempting to understand some of the soil chemistry and the pools of different nutrients, They shortly found out, the Maliks of the world, the Brays, the Olsons, the Lancasters, the people who in soil fertility, we just know these names. We've heard of them a lot of the time. They understood that just running water, they first understood that they needed to test their soil to understand what we have and what we don't have. But they shortly understood that just taking a soil, running water through it, and seeing what nutrients came out with the water, that wasn't a really good indication of what may or may not be plant available. And so they all just kind of, all separately, nobody really worked. I mean, it was harder to work together at that point. They all kind of separately figured out, I can use this little bit of acid, this little bit of acid, and this something else mixed in to work with some of the soil chemistry, extract some of those, particularly phosphorus and potassium nutrients off of either secondary minerals or either on the clay particles themselves, what we call the cation exchange capacity, CEC. We can use some of those things to pull nutrients off into solution, and then we can analyze for those solutions to see what the soil had. Now, it was to be estimated what is plant available. This isn't going to be a perfect one-to-one to one is plant available to what a plant actually has available to. And that's kind of a problem with all of our recommendations, is they're based on what we estimate the plant is actually going to have access to and get to. But even though it's really impossible to do, to actually get all that. So Malik in North Carolina, Lancaster in Mississippi, Bray in Illinois, Olson in, remind me, Colorado? Yeah, so Olson in Colorado, they all found that in their regions with their specific soil types, the mixture of random acids and solutions that they provided a pretty good estimation of what may or may not be plant available for plant nutrients. Fast forward to where we are now, and we're all talking a lot more. And each one of those extractions have their benefits. Olson in the west, on the western side of the U.S., is better on those type soils, higher pH, newer. We generally would call those like newer, less weathered soils. Malik worked better in the coastal plains, in North Carolina. Lancaster obviously worked well in Mississippi, so they were developed for those. Fast forward to now, and we're all talking a lot more. Internet communication is a lot better. We can make this phone call right now. We can talk more about, oh, well, you all are using this extraction. Why does that work there for you? Let's test that out here. And so that's where a lot of this kind of comes from, is now we're all kind of we're not saying we all need to go to one extraction, but we're talking a lot more and saying, this works here. What do you all think? Would it work in your region better? And that's kind of led to where Malik 3 now is one of the more universal extractions that we use and talk about.
Yeah, and if we look at the lab, because we both run labs, so if you look at the lab efficiency, especially at large scale, those labs at Ward, Waters, and others that are running 24 hours a day, it's not easy to run multiple extractions. You can get a couple, but to run 4 or 5 at a high throughput efficiency just doesn't work. And so, really trying to narrow down and having a couple very universal extractions tend to work. And like you said, Malik 3 is the one that we've utilized here. It works well at the more acidic range, and it's shown. Just listened to a talk the other day that it works actually well up to about a 7.3 pH, and so that gives it a nice range. Where a Bray, which was traditionally this, like you said, the East Coast acidic, it starts playing out its effectiveness around 6.5. Also, just for listeners, what I've always said is that soil testing is a imperfect science that's providing us some valuable data. So what we do, a little bit of kind of, support Vaughn's point, is that in soil testing, we're using a chemical method to extract nutrients to replicate a biological reaction, which biology has so much more variables that we can't replicate within a laboratory system. But while it might be imperfect, it still gives us a very good understanding of the lows and highs. A low soil test phosphorus will show up irregardless of the test, and the high will too. What we're trying to work on in our realm is kind of those intermediates, refining that fine line of that non-responsive. And a lot of times, Vaughn, and I think you and I have talked about it, it may not necessarily be the chemistry of the soil. It might be the physics of the soil, or it might be the biology of the plant or the biome that plant is in.
One of the things that we've had discussions on, and I've kind of had to moderate how exactly I say this, but it's our recommendations work really well on average, but you and I would be the first to say they don't really work that well.
No,
It was the best we had
Yep.
60 years ago, 50 years ago. And we're taking steps. And a lot of times, like you said, with the physical, there's some other things that, there's thoughts and some work out there that says that drought is or compaction is going to stop some things. And so you might have a soil test that says, oh, I have plenty of potassium there. But if the roots can't move through the ground and actually get to it, then the soil test is irregardless of the plant's ability to actually get to it. There's a lot of things that go into play and stuff that we just in a soil test alone is not capable of providing answers to. There's a whole lot more information that we need with that.
Well, you said a great thing. When the questions coming in and the areas that you and I are looking at. So just to be forthright, Dr. Reed and I have a fair amount of collaborations, kind of in the same thought process, and so. A soil test is typically 0 to 6 or 0 to 8 inches, and that's really just a two-dimensional look. And I say two-dimensional because you're just getting a large area. You're not getting a spatial nature. You're just getting a chemical nature, some other factors. And yet roots go deeper. At the same time that I would love to see every producer and every consultant go down to 3 or 4 foot deep. I'm not going to go to 3 or 4 foot deep. I mean, it's physically exhausting. It's time consuming. It's laborious. You can do it from time to time, but you have some challenges in that. But we've historically, Mississippi is much like Oklahoma, a very diverse state. We've had the original soil fertility folks had to have one recommendation for an entire state. In Oklahoma, we have gators and antelope, and you guys aren't a whole lot different. You don't have the elevation change, but you have some very distinct environmental differences from north to south and east to west.
One of the things that also is an impact here is, in Oklahoma, and I know it's a low percentage, or not, you all have no-till, and a good percentage, but not the majority of producers in the state are in no-till. And so that changes how we do our recommendations. We looked at, when I was there, that we even segmented out what depth works better for nutrient response, and found that really it's that middle range, that 0 to 6 or that 2 to 6 inches is really good at, even though roots go deeper, is really good at providing an estimation of nutrient responsiveness. In Mississippi, especially in the Delta region, no-till is not really possible, mostly because of the culture, the system that we have. A lot of the times, last week we've got like 6 inches of rain in the last week. We're working on you have to worry about not getting enough rainfall. Yeah. We have to worry about getting water off the field so we can actually get in. So our planting times aren't really regulated by certain times of the year. It's, can I get into, when it gets warm enough, can I get into the field? So with that, we're on, and this is the same for Arkansas and Missouri as well, as like ridge till, where we have large beds that roughly at the start of the year might be 18 inches tall. Then after so much rain, it might shrink down. So that kind of changes when you're having to constantly work the soil up and then build it up into a bed, plant over that bed, and then have to do either soil samples before, soil analysis before, soil analysis after. We have to think about the amount of water that we're putting on the field. We're not using pivots. We're not drip irrigation. We are furrow irrigation, probably the most ancient kind of irrigation strategies. So understanding what you get out of the water, the movement of nutrients with that water, it just really confounds. I mean, it's not something that we can change. It's the system that we have, but it really confounds how we make our fertilizer recommendations based on that.
So, Dr. Reed, you got any other projects that you're having fun with?
So you'll actually be proud, and I hadn't mentioned this to you off mic yet. We've actually got a nitrogen timing study going out. So for background, a lot of Arnell's work prior to me getting to Oklahoma was nitrogen. I I was there when we did some more stuff, but a lot of it was nitrogen. And so coming from there, I do have some decent background in nitrogen. We're doing some nitrogen timing in corn.
Mm-hmm.
Looking at it's really what I'm really interested in is about 3 studies down the road. But before I get to that third study, I've got to do the background information. So we're looking at trying to understand. Like I said, a lot of the time we have at the early season is predicated on when we can get in the field. And so planting is the very first thing that needs to get done. If you can get fertilizer out there, awesome, but planting is the most important part. So we're wanting to look at how late into the season. We're looking at a 2-split nitrogen application. How late into the season does that first shot of nitrogen need to go out? And then pair that with how late into the season can that second shot of nitrogen go out? We know that splitting nitrogen rates is the best way to increase our efficiencies. And so is there a first shot and a second shot optimal timing, or is it really based on weather? A lot of the things you and I have looked at before says weather is probably rainfall is the most important part. The third really down in the future is how many splits do we need to make? How many splits can we make? And then looking at really making sure those rates are accurate. So that's some of the newest stuff that actually my guys are out working on today, putting out the V8 applications on a lot of my locations today.
Very cool. You'll be hearing about it soon, I'm sure. But Dr. Sherry's been looking at a bunch of the wheat data, and his analysis is going to come out that under 80 bushel, there is zero value for split application in Oklahoma. It's a one time. Make it once, because you're losing money by taking that rig over the field twice. Just make it in that timing.
And so I'm assuming that follows along with kind of the other stuff where it's really until that right before that flag leaf or first hollow stem.
Yeah, first hollow stem, yeah, somewhere in that time frame, anywhere between that February to that time frame. Mm-hmm. One of the things that we're having fun with coming off of, and I mentioned these names because Vaughn was able to work with them, but Michaela Smith's dissertation. We're in the field this year with the cotton variety that responded the most to nitrogen deficiency in terms of root growth. And so we've got 4 plots down at our really deep sandy soil station on Cimarron Valley, where we have pre-plant high rate and applications at, I think it's 14, 28, and 30, 42 days. But we're putting AquaSpy sensors in every single plot. So 4 plots, 4 reps, and we're dropping in all the AquaSpy sensors in hopes that those AquaSpys or soil moisture sensors across the board are suggesting they can measure root growth, right? Because they're seeing how the water is being pulled towards the plant. And so we're hoping, it'd be cool if it works, we're hoping that we can utilize these soil moisture sensors to determine if we can increase root exploration with nitrogen timing and efficiency, because everything we've done is in the growth chamber, and we only take it for about 3 weeks. And in that scenario, we see massive differences, but that's also a growth chamber and a sand soil and a sand base.
That's, I didn't even, so that's, I hadn't even known that was actually a thing, that they could measure root growth.
Yeah, so what it is it's seeing that water potential change, right? Wherever you have actively growing roots, you'll see the water potential change. And so most of these sensors will have a little gauge on it to the side of their app that shows you root growth.
So I guess you just have another one close by just to say the difference in.
Well, we'll have one in every single plot.
Against no crop, basically.
Yeah. Is what I'm getting. Yeah, well, we'll have one in every single plot. We won't have in a zero crop.
Okay. Well, I guess at that point you can still compare. No, that would be, because at that point you could say, all right, this is when we're getting the most growth, and we can do some of that with nutrient uptake curve.
Yeah.
But you can do that a little better with sensors. Interesting.
Yeah.
Yeah, that would actually.
Yeah, because at least early on we aren't seeing any above ground growth. We've been talking about changing a root, and it's looking to be less about the root biomass change, but root structure and actually architectural change, where we have some roots just stay in the surface, and then when there's a lack of nitrogen, now they go deep, and so they're changing their growth pattern. So it's really fascinating work.
No, that'd be really cool to end up looking at.
Anything else you're working on, Vaughn?
A lot of my soil analysis stuff that we're working on, like you said, I do run a lab. And so right now our lab is set up to run basically any analysis anybody would be interested in. Doing a little bit of we're doing a lot of tissue analysis, mainly nitrogen, phosphorus, potassium. We're going to have some sap analysis. That was something that really came up from a lot of producer phone calls I've had. Is, do you know much about this sap analysis? In theory, the suggestions are that sap analysis, you're actually pulling out the sap, the solution from the xylem and phloem, and that's going to give you a quicker indication of nutrient deficiencies. So we're looking at some of that. Again, comparing our Malic 3, our Lancaster, and even Malic 1 fertilizer recommendations. So that's some of the work we're doing as well. So we're really attacking everything from all sides, from the field, the lab, greenhouse setting. We're doing a lot of stuff.
It's time for our famous 3. Explore the future of agriculture with KWS, a global leader in innovation and sustainable farming practices. Uncover the exceptional qualities of our hybrid rye, cultivating a legacy for a greener tomorrow. Visit kws.com/US for more information and for dealer locations. KWS, seeding the future since 1856.
Well, Vaughn, it's been a lot of fun. I'm going to hit you with our final 3 questions that I do with all of our guests. And the first is, what's your go-to resource when it comes to questions you encounter at work?
Really, depending on what it is, I either am going to Google it or I'm going to make 2 or 3 phone calls and then find somebody else. So another graduate student that used to work with us, Bronk Finch, assistant professor in soil fertility in Arkansas, him or I will call each other and ask, like, hey, what do you think about this? Where did this come from? And then eventually I'll make my way to you or some other professors here on campus. So I'll start with Google and kind of go from there.
So I know you're kind of like a struggling artist. You're a struggling assistant professor. So with all your free time, what do you do in your free time? What's your favorite leisurely activity?
Free time. Interesting.
Yeah.
Okay. I like to read and then watch a lot of sports. Like I'm about to, whenever the NBA Finals ends, I'm going to kind of go on a hiatus for a little bit I'm not a big baseball person, but yeah.
And then finally, where do people go to find more about the work you're doing in your program?
You can find me on Twitter. If you look me up, Vaughn Reed at Mississippi State, I'm on Twitter. You can find some of my work there. We're working on putting together Mississippi State has a website, faculty website that a lot of my research will be found in. And hopefully in the next couple of months, we'll have a blog started that kind of goes through like some of these questions that I'm getting. And that way I can kind of write out, here's what I've told one person on the phone call, but here's kind of it summed up so other people can go and find some of that information.
Fantastic. Well, Dr. Reed, it's been a great bit of fun. Again, this is Dr. Vaughn Reed, Assistant Professor of Soil Fertility at Mississippi State University. And folks, if you enjoyed this podcast, hit that subscribe button to make sure that you get notifications whenever one's released. Of course, share it with your friends and share it with people that aren't even your friends. Let's spread the word about the Crop Science Podcast. And if you have any ideas or questions, shoot us a note anytime. We'd be happy to hear from you. Vaughn, thank you so much for joining us today.
Thank you, sir. I appreciate it.